Bismillahirrahmanirrahim. I'm going to discuss how to evaluate equivalent resistance of series, parallel, and even more complex network. This is the first example I'm going to discuss, and I in this circuit R1 is connected between node C and node D. This is node C. The whole is node C, and this is node E, and R1 is connected between C and E, and R4 is also connected between C and E. Similarly, R2 is connected between the node C, this is node C, and node D. Similarly, R3 is connected between node D and node C. I redraw the same circuit here, and you can see R1 is still in between C and E, and R4 is connected between C and E. So it means they are parallel. Similarly, R3 and R2 can be placed like this, and they are parallel to each other. Now the circuit looks quite simple and easy to solve. Let's solve it. R1 and R4 is replaced with a single resistor. Similarly, R3 and R4 also connected in parallel, so replace with them with a single resistor. So R1 is in parallel with R4, and R7 is the equivalent resistance of these two resistors. R7 is equal to 4 ohm. R3 is in parallel with R2, and R8 is the equivalent resistance of these two resistors, and R2 is equal to 2 ohm. So R1 and R4 will replace with a single resistor of 4 ohm, and R3 and R2 is replaced with a single resistor of 2 ohms. Let's redraw the circuit. So R7, which is equal to 4 ohm, and R8, which is equal to 2 ohm, and now the circuit is simplified as this. Now all are in parallel, or that is R5, R7, R6 and R8 are in series, and the equivalent is this. Now come to the next example. This is another circuit. The circuit seems to be difficult, but it is not difficult actually. You can see R4 is connected to R2 like this, and R3 like this. R4 is in parallel with R3 because they share the same two nodes. That is, this node is common between its terminal, and the second terminal is grounded. Both have grounded, so they are in parallel. Replace them with a single resistor. It can be redrawn like this. That is, this is R3 and this is R4. They are connected like this. R3 is in parallel with R4, and R5 is the equivalent resistance of these two resistors. R5 is equal to 342 ohm. So the equivalent resistance is 342 ohms. The circuit is redrawn here, and now R2 is in parallel with R5, and we replace them with a single resistor R6, which is equal to 500 ohm. Now redraw the circuit. The circuit is redrawn here. Now R6 and R1 are in parallel because one of the terminal is this and the other terminal is grounded, so they are in parallel with each other. R1 is in parallel with R6, and R6 is the equivalent resistance of these two resistors. and R6 or R equivalent is 250 ohm. This is the last circuit. In this circuit there are 8 resistors, and so there are 8 resistors and these are in series. These two are also in series, and R6 and R7 are also in series. So let's redraw the circuit and replace all these 3 resistors with a single resistor. R2 is in series with R3, and R9 is equal to R2 plus R3 is equal to 25 ohm. Similarly, R4 is in series with R5, and R4 plus R5 is equal to 50 ohm. R6 is in series with R7, and it is equal to 50 ohm. Redraw the circuit. Now there are two nodes A and B. R10 is connected between A and B. Similarly, R9 is connected between A and B. In the same way, R11, which is connected between B and A as well. This is connected to A as well. So R9, R11, R10 all are in parallel with each other. So and their equivalent is 12.5 ohm. So these 3 resistors are in parallel and can replace with a single resistor of 12.5 ohm. Now R1, R12 and R8 are in series and can be replaced with a single resistor of 22.5 ohm. I hope you understand. Thanks for watching. Goodbye for now.